Welcome everyone. Welcome to the March edition of Flower Monthly. This is the second monthly installment of community updates that we've been running. It's a pleasure to be here. My name is Nicholas Lane. I'm joined by the two co-creators of Flower, Daniel and Tanner. I'm also, it's a pleasure to introduce Rob Norvill, who will be giving our sort of premiere talk at the end of Flower Monthly as we get through the sort of a few announcements at the start. And of course, many of you will be very familiar with Charles, who's been doing fantastic work in building out a lot of really useful components for the ecosystem. He's also going to be speaking today. So I basically just want to say welcome to everyone. Welcome to the March edition of Flower Monthly. Before we get into the meat of the meeting, I just wanted to sort of again, so summarize what we're trying to achieve here with Flower Monthly. This is a monthly engagement of the community. We're going to try to keep the timing and the day very regular. So the first Wednesday of the month, beginning at 5 o'clock GMT, where there's a time zone that works, in many different locations in the world. This is going to be a regular and formal sharing of information for the community. We're going to invite some amazing speakers like we have done today with Rob. These folks are going to tell us about perhaps research that they're using Flower for, or in this case, real world use cases that are really transformative in terms of how they can allow federated learning to change the way we do very important functions such as banking. We'll also be announcing updates to the framework. There's going to be periodic announcements from working groups and Flower sites. And suggestions are always extremely welcome to this meeting. It's really, these meetings are for the community to engage. And so if you have any ideas on how we can improve these meetings, please reach out to us. The most easiest method would be on the Flower Slack. And there's a special channel there called Flower Monthly, if you want to use that. So with that, I'm providing a sort of a foundation with what we're here to do today. Let me tell you about the agenda. We're going to make an incredibly important announcement in a few minutes, and that is going to be this year's Flower Summit. We're going to announce the date and sort of the format of this annual meeting where we all come together physically or virtually and see how far we've come and see what's the roadmap moving forward. After that announcement, Charles is going to be giving us an update on Flower baselines and some of the advances we've made on that front in the past month. And then to conclude, we're going to have Robert, who's a senior data scientist at Banking Circle, telling us on how federated learning can be used for money laundering detection and enhancement, which is a really important area of the financial system. So that's the agenda for today. Let's move forward and talk about the Flower Summit. And so the Flower Summit this year is the third installment. It's the third year that we've been running the Flower Summit. I'm happy to announce the dates are going to be May 30th and 31st. And so if my memory serves me correctly, these are very similar dates to what we used last year. The venue is going to be a hybrid event again. So Zoom participation is going to be really fully embraced. We'd like to see people around the world the same way they did last year and the year before. But we also recognize the value of physical interactions and community building of that kind. And so there's going to be a physical venue for this summit. It's going to be in Cambridge again. And so just if I advance the slide, I can give you even more details about this exciting next installment of Flower. This time, because we had just unprecedented demand last year, we had 500 registrations. I think it grew 3 times from the prior year last year. And so we've taken this into consideration. And especially we've seen a lot of uptake in industry usage of Flower. And simultaneously, we really like the engagement of researchers and how they're using the platform to experiment with their ideas and understand how federated learning can move forward. And so we've decided to expand this year into a 2-day event. One day will be focused on bleeding edge research that's commonly being done in industry labs and academic environments. And the other day will be focused more heavily on industrial and real world applications. In both cases, it's using the flower ecosystem. And so, and hopefully we'd like to see people attend both days, but we know during time constraints, maybe you can only pick one of these venues, one of these days. So please pick the one that makes the sense for your type of usage. As I mentioned earlier, it's going to be a physical and virtual event on the 30th and 31st of May. The type of timings we're planning to use are starting around 1:30 local time in Cambridge. And then we'll be going all the way into the evening. And we've designed that so that people from around the world can listen to the talks more comfortably, depending on where they happen to be physically situated. This year, we're also going to have a very conscious call for speakers. Flowers expanded so much more than we ever would have expected. And now there are people using it around the world that we've never even spoken to. And so therefore we need to make this nice and accessible for the whole community to engage. And so if you go to the website, you'll see that there is a call for speakers. So if you would like to contribute, tell the community about what you're doing, how you've extended flower and so on, please submit to that form. We want to really engage fully with the complete community. And so please take advantage of that opportunity. Also, if you're coming physically, we really would recommend that you register early. We're very fortunate to have been hosted in the famous computer lab of the University of Cambridge. And so they've given us 2 large rooms on both days that can, I think they can fit about 200 or 250 people, but that might not be enough. And so we'd really highly recommend that you register early so you can secure a physical spot if you are planning to come in person. If you do come, you're going to see a really rich set of talks, of people using flower, but also tutorials, how-tos, industry case studies, and alongside those will be research results that we're really excited by. The final part of information there on this slide is the URL that you can find that's live right now. You can go and submit your call for giving a talk in the venue and find out additional information such as where can you stay if you're coming to Cambridge, how can you travel there, and so on. For those of you who weren't at last year's Flower Summit, I want to give you a bit of an overview of who spoke at last year's summit. I know that the community has expanded a lot, so maybe some of you weren't around back around May in 2022. And this is a snapshot of some of the speakers that we had. So you can see there, we had Peter Masterson of Google and ML Commons speaking about the collaboration between ML Commons and Flower towards standardization of FL frameworks. We had industrial researchers from, for example, TCL and Brave, speaking about how they can utilize Flower to prototype and explore important applications in their industries. We had presentations from folks building startups that are based solely on that leverage heavily the Flower ecosystem to explore some vertical that they see as important. We had academics such as Afra from the University of Washington, really looking at the edge of what FL is capable of. And then we had, again, large corporates such as Orange, Italco, or Intel, looking at how they use Flower and FL in general to bridge the gap between what ML can do today and what we need to have ML do in the future. So that's the type of snapshot of, if you came last year, that's what you would have seen. We can't wait to see who wants to speak this year. We'll also be reaching out to folks that we're aware of to give it a nice full range of topics. So with that, I'm really delighted to see Flower Summit this year. And so I hope to see you all there, either virtually or physically. I am now going to hand over to Charles, who is going to be speaking to us about exciting advances in Flower baselines and other types of ecosystem components that have occurred in the last month. And Charles, if you speak, I'll just advance the slides so we can move things along.
Perfect, thanks. So hi, everyone. I'm going to quickly go over a few updates, as Nick said, and also a new example we added to the Flower repo. So just first of all, to explain what baselines are, if you're unfamiliar with them, maybe you can go to the next slide. So baselines are basically Flower implementations of an experiment from a research paper, and they fit into this larger project that we have, the FL Startup Pack, where we want to provide the community with standard datasets, models, and strategies in order to quick start the process of using federated learning. And so this month, we released a new baseline. If you go to the next slide, which is the FedProx plus MENS baseline. So basically, this baseline is very similar to the previous baseline we released, which was the implementation of Federated. But the main difference lies in the, if you go to the next slide, in the objective function. So here we have the objective function of the Federated paper. We just call it fk of w, where k is just the client, and w is the weights of the model. And if you go to the next slide, we can see the main difference with FedProx, where here we've added the regularization term. So mu over 2 times this term, which is actually called the proximal term. If you go to the next slide, I think it's just highlights. Yeah, so this is the proximal term, and this is the important part of the baseline that makes it basically different to Federated. And if you go to the next line, basically the next, sorry, just focusing on the proximal term here. The first W is the local parameters, just as before. And then on the next slide, you'll see that the WT is for the global parameters that were sent by the server to clients at round T. And so this regularization term actually allows the clients not to diverge too much from the central model, and so it should provide better convergence for heterogeneous data. If you go to the next slide, so now for the upcoming baselines, so this is probably going to be released over the next few weeks or month. This is actually a pretty big one, because this is the feminist experiment from the LEAF paper. This paper is actually a benchmark of many data sets with many models. And here we're focusing on the feminist data set, which is actually an extended version of the MNIST data set that we used for the previous baselines. And so, yeah, this is going to be the next release of in baseline. Normally, baselines are always open to contributions, and we have a few contributors that are actually interested in working on a few baselines. So if they are fast enough, they might even release their baselines first, but this is the main one we're working on. And if you go to the next slide, I also wanted to talk about the FastAI example. This is something we released also this month. And if you go to the next slide, FastAI is actually, their motto is to make neural networks uncool again. Basically, they want to try and simplify the whole process of training neural networks. If you go to the next slide, we can see that here, this is basically the whole training and evaluation of a model. And as you can see, it's just 5 lines of code. So this is a great framework, especially for people that want to get started with machine learning as generally. And it also allows to go much deeper if you need to. And so to integrate it with Flower, we only needed to tweak a few things. If you go to the next slide, you can see here that we're going to take the learn objects that we create with FastAI, the FastAI API. And from that learner object, we can actually access the PyTorch model and state dictionary, because FastAI gives a wrapper of PyTorch in a way. And then the different steps, maybe you can go through the next slide. It's going to be pretty quick. I just broke down the different necessary functions. So here it's just using the learner object. If you go to the next slide, it's going to be very similar. We just access the state dict using the learner object. And then for the training, for the fit function on the next slide, you can see here, we just call dot fit and the number of epochs. Here it's just one local epoch. And on the next slide, we're gonna just evaluate our local model. And as you can see, it's very simple to integrate this into a federated setting using Flower. So feel free to check out the blog post we wrote about it, maybe if you want to go into more details, and be sure also to check out the GitHub example we have on Flower. And yeah, that's about it. I don't know if you have any questions.
I had one question. I was going to say, in the FastAI example set, they both do a lot of images and NLP and different things. Have you seen? Have you tested these on the NLP tasks yet, or just the image ones?
Yeah, well, I actually run into an issue with when trying to federate with Flower, is that I think the way they train their model is actually quite resource intensive. So when I was using some bigger models, running 2 clients on the same machine, it was kind of struggling. And so this is why for this example, I used, I think the name of the model is actually a SqueezeNet or something like this, which is quite a reduced computer vision model. So I guess if you really distribute it on a server without using the ray simulation, you're probably going to be able to train much more complex models like NLP models. But on a single machine, from the testing I did, it's pretty slow compared to other frameworks.
Well, these are both, brilliant additions to the framework. I've seen a lot of people looking for FedProx. I mean, it's a classic thing to compare against when you're doing Fed average, and so those are the 2 foundation building blocks we now have. It's going to save people so much time. They don't have to reinvent the wheel every time they want to write an interesting technique. And then FastAI has really been transformative for the community. So I'm happy that we're really going to be able to tie up with that large community and join them with the one that we're building here. So yeah, that's amazing. Thank you, Charles. It's always impressive what you can do each month.
Maybe one thing I could add about the FastAI example is that we wanted to try and stay as close to what they recommend for the beginners. So we use the default functions. And this is probably one of the reasons we have some performance overhead, is because they use quite extensively some, I won't say graphics, but it's not really graphics, it's just the progress bar. And I think for multiple clients to display it on a single terminal, I think it induces quite a bit of issues when using quite a bit of data. It might be, because I'm not sure, but yeah.
That makes complete sense. I guess it wasn't made to be used in a multi-client scenario. So it makes complete sense. We can maybe we can talk to Jeremy to see what might be done to bridge that gap. I'm sure he'd be excited. So we'll make sure we tick that box. Well, I'm conscious of time.
Maybe a quick thank you from my side. I think the FedProx example and baseline was one of the most requested features of all times that we had. So I think from what I've heard, the community is quite excited to finally have this.
Great.
Excellent, excellent. Well, with these announcements out of the way, I'm really delighted to move on to the sort of main event. The main event of Flower Monthly this month is going to be our invited speaker. We have Dr. Robert Norvill of Banking Circle. He is a senior data scientist working in the area of finance and banking. And in fact, I can't think of anyone better in being able to bridge two important worlds, the worlds of finance and banking and the worlds of federated learning, which seem to be unavoidably heading towards each other as we start to understand how to untangle all this financial regulation that's so important. So Robert, thank you so much for joining us today and being willing to speak to us about the important work that you're doing. Thank you so much. I'm going to stop sharing it and give you the floor.
Great, thank you very much, and thank you for having me today. So, yeah, my name's Rob, as already been mentioned. I'm a senior data scientist at Banking Circle, and I spend at least some of my time kind of leading our effort in federated learning for anti-money laundering. So today I'm going to take you through who we are as Banking Circle, our present AML solution, and how we use various tools, including machine learning, to do what we need to do. Our use case for federated learning, and then the federated learning solution we've built, and there I'll cover kind of some of the experiments we've run and what it looks like from our point of view as a bank, and how we see it going forwards. So Banking Circle, as the name suggests, we are a bank. If you haven't seen us on the high street, that's because we're a B2B bank, but we do operate around the world. We have offices in Copenhagen, London, Luxembourg, and Singapore. At present, we facilitate 10% of Europe's e-commerce payments flow, which means we're handling 2 million payments every day. So when it comes to kind of AML requirements and compliance, we have to be pretty on the ball. We've got a lot of payments going through us, and we have to make sure they're all processed properly. And we need to make sure that everything we do can scale in accordance with that. So our kind of overall goal as a business is faster, cheaper payments. We think that cross-border payments, should take 5 minutes and cost 50 cents. At the moment, they take 5 days and cost 50 euros. But we're here to solve that problem. And we do that by having all the related financial infrastructure that are required for payments, cross-border payments, all in one place. So what do we do for AML currently? Well, not everyone works in banking or finance, so I'll start with a definition of AML. Eurolex describes money laundering as the process by which criminals sorry, my screen went for a second. The process by which criminals conceal the illegal origins of their property or income. And anti-money laundering is what we have to do as a bank to prevent this happening. So for us, it means looking at payments. We process, as I've just said, millions of payments, and we have to look at every single one of them to make sure nothing untoward, nothing illegal or fraudulent is happening there. And if we do find something that looks suspicious, doesn't look right, then it has to be reviewed by a human, by one of our analysts. And then if it's confirmed that something was wrong, we have to report it to financial regulators. So in the UK, for example, that's the FCA. There's been a trend in recent years for kind of an increasing regulatory burden on banks. So there's more and more legislation around stopping money laundering and financing things that shouldn't legally be financed. And it falls to the banks to make sure that this doesn't happen. So one thing is that we're having more and more payments to process as a growing bank, and the other is that there's more and more that we have to do to remain compliant with current laws. So this is what our current setup looks like. I won't dig into all the details here, but but there's a few things worth noting. So payments come into the bank, and then we have a number of automated steps to kind of highlight which ones we do need a human to look at and which ones we don't. So the first thing is kind of static rules, which might sound a little old-fashioned if I'm speaking to a machine learning audience, but payments are very good structured data for the most part, so we can do quite a lot of filtering just with static rules. So that's our first thing. Then we have the supervised learning models. So this is where we feed payments into a pre-trained model to try and figure out whether they look suspicious or not. There's a few other steps in between, and ultimately the ones that our models say look suspicious, an analyst, a human, checks. And they kind of give us our ground truth. So what the analyst tells us is either yes, this is a fraudulent payment, or no, it isn't. And that's fed back into our machine learning models. And when I come to the federated learning part, that very much fits into the supervised models. So we're kind of retraining for federated learning for certain things, which I'll cover in a second. I think a few key points about the machine learning supervised learning part is we use TensorFlow neural networks at the moment to make these predictions on payments. Input information for the model, so our features, you could probably guess some of them. It's payments information, so the amount associated with the payment, the names of the sender and receiver. If there's a free text message, we'll analyze that. Which regions is the payment going to and from? We do have a lot more features, actually, and some of them are kind of calculated features, which we use historical data for. But to give you a flavor, it's those kinds of things going into the model. Output is we would call it a risk score, which is how suspicious does each payment look. So 0 is completely fine, and 1 is the model telling us there's something wrong with this payment. And then anything above a certain threshold, we send off to our analysts to investigate. And I think another thing that's particular to payments data is it's extremely imbalanced. So there aren't actually that many bad or fraudulent payments going around, despite what the news might tell you. So we can have millions and millions of payments and still not have much to work with in terms of true positives. So there are ways to counteract that, but it's a kind of peculiarity of payments, let's say. And I think it's probably also worth mentioning here that we need to be kind of highly accurate on all fronts. So if we're missing potentially fraudulent payments, then you can land yourself in a lot of trouble with the regulators for not doing what you need to do as a bank to make sure you are stopping fraudulent activity. But if our false positives get too high, then we drown our analysts in work and we can't check the payments anyway. So there's a sweet spot, but it's a very small sweet spot. We have to be fairly accurate on all counts. So to get to federated learning, Banking Circle is now opening in the USA as well, as in Europe and other places around the world. And our US entity will need to do the same or very similar in terms of AML and transaction monitoring. But because it's a new entity, it will start life with 0 payments. It won't have any. And because of data privacy and data protection, it's sometimes tricky to kind of share personal private data, which transactions certainly are across borders, especially if you're talking about going from Europe to the US. It's a little easier the other way around, though. So we drew up some goals that we wanted to achieve with federated learning. What we're looking to do is build a kind of performant US payments analysis system without enough data. And when I say enough, I mean enough data to train a standalone machine learning model for the US. As I mentioned, because of this imbalance, we can have potentially a very large number of US payments and not still have enough data. So we could just use the EU model in the US, but we think we can do a lot better than that with federated learning. So we can begin to build a US model even with relatively small amounts of data using federated learning, and I'll explain how on the next slide. Another goal is obviously, as I mentioned, be data protection compliant and data privacy compliant, which makes federated learning and Flower a natural fit because we don't move the data. And then we have a kind of more medium-term goal, which is even once we can train a US model standalone, so we have enough data in the US, is there anything our EU model can learn from the US model? So we will keep federating even when we have a lot of data and see if there's anything that these international payments in different parts of the world can learn from one another. So I'm not sure, honestly, if this slide is redundant, but I don't know everyone who's watching. So I thought I'd give you a quick, what is federated learning? For our purposes here, I've kind of defined it as training a model across multiple servers using local data samples without exchanging the data. So if you have no idea what federated learning is, hopefully that gives you some idea. For us, for this use case, at least in practice, this means that each client trains a model locally on their own data, usually for one round. The client sends updates to the server, and the server aggregates them. We use a particular algorithm to do this. Those aggregated updates are sent back to the clients, who begin training again for one round, and then we return to step 2. And we can do this as many times as we need to get good and accurate results. So allow me to introduce Flame, Federated Learning for Anti-Money Laundering Enhancement system. This is kind of a real high level of our architecture here. So because of the nature of our problem, we don't have a lot of clients. I know a lot of federated learning use cases do, but we have 2. One is our US bank and one is our EU bank. They both have as their data sets their own local data. So payments originating in Europe or payments originating in the US. And the Flower server is obviously responsible for aggregating the updates that arise from training the model on these 2 data sets. We use Azure for pretty much everything internally. So all this is in the cloud on Azure virtual machines. At the moment, we still use a short-lived Flower server. So when we want to train or retrain, all these things spin up, do the training for as long as it takes, and shut back down again. And we use the classic FedAVG, or FedAverage, if you prefer, algorithm at present, although obviously there might be scope to try using different ones in the future. So just to elaborate a little bit on the use case and what we expect Flame to do, we're primarily concerned with increasing performance for the US side. So we're already live and running in Europe with plenty of data there. So when we're training our federated model, we're training a model for the US only. So our primary thing is, can we get a better model for the US side? Which makes the situation kind of interesting because we actually don't have to make a model that's performant for all clients, in this case, only the US side, which gives us a bit more scope in kind of what we would tweak and change and how we would change it. When we very first launch, the US entity will start with the current EU model, and we'll do our retraining from there. So the first time we train a federated model, both sides have the EU model, and they train with different data. After that, the starting point becomes the federated model, which is the US model, and we'll retrain using that. Because we expect the transaction volume in the US, or payment volume in the US, to be increasing fairly rapidly, we look to retrain using Flower every week. So as the amount of US payments we have increases, we keep retraining to get higher and higher accuracy, is the idea. And this kind of has a nice kind of passive effect that because contribution to the federated model is weighted based on in our case, the number of payments that each client provides, that the US side takes, excuse me, sorry, the US side takes more and more influence over the model as time goes on. So I should stress that we're not live in the US just yet. Banking Circle is launching in the US, but we're not yet launched. So we don't have real live US payment data. So we set up a number of experiments to try and simulate what we think that would look like. So we took a large number of European payment data, which we do have, and split it in half. So 50-50 split, and each split formed one data set. So one being Europe and the other being our simulated US data set. 10% was taken for eval, another 10% for test from each, and the training data set is oversampled because of our imbalanced data. We did play around with a few things. We played around with using Fed AVG, but weighted on the number of true positives, but simply weighting it on the number of payments trained on provided the best results for us so far. In terms of testing, we trained baseline models. So a baseline model we take to be a model which is trained on one of our two data sets. And then the federated model is trained using the two clients, EU and US, each which have one of these two data sets. And the results, I'm pleased to say, look like this. So this is the federated model versus the baseline model that was trained on one of the data sets. You can see we get big increases in all three metrics, the largest being precision, which went way up compared to the baseline. So this is exactly what we would both want and expect to see to replicate kind of how we would see it going in the US when we go live. But yeah, especially precision there is way up at 60, 68, 69%, I think it is. So that was great. We then also tested our federated model against a model trained on both data sets. So this is kind of an unfair test, I would say, for federated learning. It's federated learning versus all the available data. And at least for accuracy and recall, they were comparable, which was great news for us. Precision did lose out a bit. Maybe we can also get that there with a little more tweaking. But just as a stress test, we're kind of seeing that for payments data, that federated learning can really hold its own. And then the last kind of experiment we did, so I mentioned that we expect once we go live in the US that the volume of payments increases over time as more and more payments come through the bank. So we took one of our two data sets, split it into 10 parts, 10 chunks, and then ran an experiment adding in an extra chunk each time. So experiment 1 is 1/10 of the data, experiment 2 is with 2/10 of the data, and so on. Here, Flower simulation was incredibly useful because we could essentially do all 10 experiments just in one loop with the simulated client and server inside. So that was nice and easy for us to do using Flower. And the results there, as you can see, the short story is more data, better results. But it was very encouraging to see that this worked in the federated environment as we'd hoped it would. So the leftmost graph there is the final metrics from each experiment, and the other three are the per round results from experiments 3, 6, and 9 respectively. But yeah, again, this was great news for us in terms of simulation and what we would hope to see going live. So that was really good news. Future work, I already mentioned it. The obvious one is go live. We need to see this work with real US payments. So Flame is built and ready to go. So as soon as we have US payments coming in, we'll start running it. Even if it's just one US payment, it'll be run and then rerun as the volume increases. One thing I'm quite interested in looking at once we do have real data coming in from the US is to experiment with different neural network architectures. So I think a more complex architecture might help. What we saw in some of our really early experiments, if the two data sets were extremely disparate, is that you lose performance overall. It seems like the two different data sets and different models are pulling the federated model in different directions. But my suspicion is that a more complex network would allow us to capture the differences between the two data sets rather than canceling them out. So that is future work. Going beyond that, looking ahead, the experiments we've done here, I think are a pretty good kind of simulation for what we would see with our US entity. But it also looks very similar to what you'd see if you had a kind of inter-organization AML model training. So one thing we're interested in is a potential wider collaboration on kind of anti-money laundering and fraud detection. So it could be the case that Banking Circle trains on its local data, another bank trains on their local data set, a payment service provider trains on theirs, and using Flower, using federated learning, we can produce one more performant federated model overall. So that is kind of where we are now, the experiments we've done, where we want to be in the future. My email address is up on the screen there, so if after this anyone thinks it looks really interesting or has any thoughts about collaboration, you're more than welcome to get in touch with me. Or I'm sure if you get in touch with the Flower guys, they'll be able to connect us as well. Thank you.
Amazing. Thank you for the talk. And so we're getting a few people going to ask questions. And so I'm going to take a few questions now. We have a bit of time. So if anyone's out there, you just raise your hand. We're using the system so we can have a bit more scalability in our Zoom sessions. I'm going to take a question from Pedro. Pedro, I think, was the first to ask. Pedro, I'm going to allow you to speak. Please ask your question.
Hello. First of all, thanks for the presentation. It was really, really good. My question, it's actually about the very last part of your presentation in terms of future work. We have recently participated in a challenge, the privacy, UK privacy challenge from NIST, where we had to create a vertical federated learning solution for this. So we had to consider banks that had information about transactions and these information were divided amongst different banks. So my question would be, have you thought about this kind of approach to federated learning that's not just horizontal, but rather vertical, so that you will have to collaborate with other banks to create a distributed model that will never, let's say it will never be able to run only on one specific bank?
Yeah, it's an interesting question. I think, as I said in the presentation, it's certainly future work for us. But I think there's potential there. I certainly don't rule it out. It sounds like you've already done some interesting things in that area, so feel free to drop me an email if you think it's relevant, and we'd be happy to discuss it further.
Great, thank you.
Sure.
Great. Thank you, Pedro, for your question. Let me just make sure I'm using this thing properly. Okay. Next question that came from Javier. So actually, Javier gave a great talk last week. So it's good to see community interaction here. Javier is at Samsung AI. Good to see you, Javier. Let me let's see, allowed to talk. Yeah, there we go. Javier, please ask your question.
Okay. Yes. Hi. Hi, Rob. Thank you for the talk. So my question is maybe a bit more, also a bit technical, and it's about the data. And in particular, did you have to do any kind of data pre-processing, for example, that you found to be essential for federated learning to work in your experiments? And also, as a follow-up, did you consider any kind of data augmentation that makes sense for your particular use case?
Sure. So I'd say internally, there's a lot of pre-processing we need to do with payments. In terms of it being specific to federated learning, luckily, because we already use AI, a lot of it is done. One particular consideration I would say is when we're making the splits in the data, you have to be careful not to have transactions from the same client in both data sets, because that's kind of cheating, right? And both sides are seeing the same client. So there was a few considerations like that. Exactly how do we form the splits? And in fact, we split the data in a number of different ways. So I have bunches of experiments all done in different data sets, split in slightly different ways. That's an issue for what we're doing now, the simulation. In terms of when we have live data, there's a little bit of a question over whether there will be any features specific to the EU or the US only, so not shared. And in that case, we'd just be taking the common features to both.
I see. Okay. And just one final question. I think you didn't talk about this, or maybe I missed it, but what kind of architecture are you using for this? Is it like a it's like CNN, or it's like a set of, I don't know, random forest or something?
Yeah, no, just CNN. Yeah, TensorFlow.
CNN.
Yeah.
Okay. Okay, thank you.
Great, thank you, Javier. Next, let me. Okay, so next would be.
Sorry, just if I might, just to elaborate on Javier's question, we do also use tree-based algorithms, but for different stages. When it's supervised learning, yeah, it's TensorFlow neural networks.
Oh, I see.
But
Okay.
there are unsupervised methods in other parts of the chain. Yeah.
Okay, great. Let's now go to Anand Henry. So Anand, I'm just going to open the mic for you. You have a question, please ask your question.
Hi, can you hear me?
Yes.
Okay, great. Hi, yeah, I'm Anand. I'm curious from an economic perspective, like what is the incentive for banks collectively to train the model and get better results? I understand that they have a regulatory obligation to report these suspicious findings, but beyond that, beyond the government asking them to do a reasonable measures, do they have incentives to actually identify the true positives better beyond the reporting requirements?
Sure. No, that's a really good question, and you're right that part of the motivation is just cost reduction, right? You have to be compliant, and if federated learning helps you be compliant more easily or faster, then that's a motivation for banks. I think there is potentially a lot of work that could be done in the future to monetize it based on contribution and things like this. But it's by no means a trivial question exactly how that monetization takes place. But yeah, I think there's a lot that could be done with incentivization to make different players join a potential federated network in the future.
Okay, thank you.
Great, thanks so much for your question. We should go now to Xinqi. Let's see, allowed to talk. Xinqi, please feel free.
Hi, can you hear me?
Yes, loud and clear.
Yeah, I guess you just mentioned that currently you are only using the features that are common in both EU and US. So do you think there might be features like only existing in US or existing in EU, but still may be contributing further to the models? So it would be more like a semi-vertical settings, some of the overlapping features, but some of the unoverlapping features can all contributing to the like one common models. And also I have another question is that would you be considering like more like protecting methods such as the differential privacy on the secure aggregations? I'm just understanding that there are some papers saying that even if you share your model, you can still leak some information. I'm just wondering, like when you share models between like international, between different like EU and the US, do you have any like requirement or regulations like require you to do some analysis to make sure like the model is secure, like do not leak sensitive information of the clients? And if so, do you planning to implement like further methods on it?
Sure. So to answer the first part, we don't anticipate many features that will be unique to either side. It might be one or two, perhaps, but not a lot. So it becomes a question then of what's worth doing effort-wise. If it starts to look like there's a few really important features that are exclusive to each side, then yes, it might be worth factoring in. To answer your second question, if looking further into the future, there's some kind of inter-organization collaboration between banks, for example, then things like differential privacy become a lot more relevant, and I think would potentially be more necessary there. Internally, we at present don't have to do anything special for it, because although they're different legal entities, we're the same bank, it's all within banking circle. So our main concern there is just not moving the payments. So we don't want to see EU payments sitting in the US. This would be a no for regulators.
Thank you.
Great questions here. Let's see. And so our last question is going to come from Tanner. Tanner, I think you can speak already if I'm. Right.
Yeah, thank you.
Yeah, great.
Hey, Rob, thanks for the talk. Do you expect there to be patterns which you can only detect if you train a model on the data of 2 regions, or yeah, how is there any expectation if that will influence models?
It could be. It's quite hard to say at the moment because we don't have the live US data. I think if we need to, we could probably split the data we currently have. So split the EU data down by country, perhaps, to kind of replicate this a little bit. But that could be of limited use because when it's all inside the EU, you're dealing with more or less the same laws across country, which means the payments tend to look fairly similar. But yeah, it could be something we see when we go live in the US.
Okay.
Did I understand your question correctly? Did that?
Yeah, that was the question. And the second one would be, how would you deal with this without federated learning?
Without federated learning, what we would have to do is more or less run the simplest way would be use the EU model as is in the US until the US has enough data to train its own model. Which gives us a potentially large period of kind of suboptimal performance, which doesn't really work with the transaction volume we have and expect, partly just because it becomes infeasible to hire enough people to look at these things manually if you're not accurate. Yeah. I mean, I think there's probably other things you could do, maybe something with transfer learning, but at the moment we see that federated learning gives us the best possibility for this progression as more and more data comes in to get more and more accurate over time.
Cool, thank you.
Great. Daniel, you have the last question.
Yeah, my question goes in a similar direction. I love the point you made that you're now able to use a model and refine a model and train a model in the US even without enough data. And I think this is something that we see in many cases where it's not so much about just improving the model, but really being able to train a model at all. Because oftentimes when you're just starting out, or it's actually the case in many for many tasks, the amount of data you have in a single location, in your case in a single region, is just not enough to train a model at all. A good model architecture, like a modern neural network architecture. I found it super interesting to see the performance difference that you get out of the from using federated learning versus without federated learning. And I wanted to ask you, would you expect the performance difference to be even larger once you have the real US data? Because the US data is probably following a different distribution slightly. And right now, both of the partitions that you have, they're coming from the same distribution. So once you have the US data, you have a different distribution in there. And I would guess that this makes the performance difference even larger, right?
Yeah, I would say so. I mean, the easiest way to prove this, right, is I come back and tell you what happens once we have the US data. But yeah, I would expect it to look something like that. Yeah.
Yeah, we'd love to welcome you back for sure.
But I should say just in closing that Flower has obviously been instrumental for this. We have played with other kind of young federated learning frameworks, but Flower's been by far the easiest to work with. I was looking actually to see if there's any more contributions I could make to the GitHub repo, but Flower keeps doing what I need out of the box. So these guys don't get any of my coding time, unfortunately.
I'm super happy to hear that, but I'm obviously thinking about how we can involve you more.
Yeah, we'd love to involve you more.
Yeah.
Well, this has been a great talk. I haven't heard a better talk on banking in FL ever. So thank you so much for joining us today and telling us all about it. And I was really happy to see so many folks in the community asking really engaging questions about the world of finance, because so many of the data sets, and at least in the research literature, center actually on images and so on. And so there's much more than that sort of workload out there. So this is a great meeting of communities here. So yeah, thank you again, Rob. Let's give Rob a round of applause.
Thanks so much, Rob.
Thank you all. Pleasure.
So then I'll just share the final slide to close the meeting. And that slide is to announce next meeting. We'll be back again 1 month from now, approximately. It'll be the first Wednesday of the month, which lands on April 5th. Again, 5 p.m. GMT, 9 a.m. if you happen to be on the West Coast and various times in between, or if you're elsewhere in the world. The Flower Monthly videos are going to be posted to the URL you see there. Please give us feedback on the Flower Monthly Slack channel if you have thoughts on how we can improve these meetings. And in general, there's the Slack workspace, which is a really great vehicle to not only talk to us, but talk to each other. And finally, I want to remind you all, if you're curious about the Flower Summit, which is basically like Flower Monthly multiplied by 100, and with a physical component, please consider saving those dates in your calendar, perhaps coming physically or at least joining us virtually, registering on the pages that are now on our website live. It's been great connecting with you all, and I will see you next month. Thank you, everybody. Take care.
Thanks.
Thank you all. Goodbye.
Bye-bye.
Thank you.